Okay, so let's talk about rewriting linear equations. And I know we're going through some of this for more than the first time, but I think it's extremely important that you get these skills down pat. Okay, it's a combination of the literal equation skills we learned earlier in the year, plus being able to interpret them. Find the slope and the y-intercept with the equation 2x plus 3y equals 9. Now, I'll tell you what kids do wrong or students do wrong when they answer these questions. People will say, what's the slope? And they'll say, oh man, I know the slope is 2 because the slope's always in front of the x. Or, y-intercept, that's always the number all by itself at the end. The y-intercept is 9. And that is not true. It has to be in the proper form before you can say what the slope and the y-intercept is or are. So the way we do that is we solve for y like a literal equation. Step 1 is to subtract 2x from both sides, okay? As a matter of fact, you know what? I think you know this from here. Take it from here, get it to the end using a little stop and start, and then I'll show you the correct answer. Go ahead. Okay, so that gives me 3y is negative 2x plus 9. Then I divide everything by 3. That gets the y all by itself, and it says y equals negative 2/3 x plus 3. So that means that the slope is negative 2/3, the y-intercept is 3. Why do we use a B for y-intercept? Because it's where you begin. Why do we use an M for slope? Because it's how you move. So I begin at 3. On the y-axis, that's the y-intercept. Now I'm going to go down 2 over 3. The negative tells me to go down. I'm always going left to right. Down 2 over 3. And then I can fill in the backside. Then I can go to the left from the original point. But just make sure it maintains a straight line. Okay? And there it is. There's my line drawn. That's where if I went on the backside, I would go up 2, but 3 to the left to keep that line straight. Okay? So that's graphing using that method. Now, this is a situation where I would not want to use graphing with intercepts, because if I make y equals 0, I'm looking now at my top equation here, 2x plus 3y equals 9. If I make y equals 0, then 3 times 0 is 0, that goes out, and 2x equals 9, then you divide by 2 and you get x equals 4.5. So if you remember, I said to you earlier that the big limitation on the graphing with intercepts is when you get fractional quotients upon division. So you want to make sure that when you do this type of graphing that you're using slope y-intercept as your primary form, and you only use the intercepts method when both coefficients of x and y divide into whatever that number is, the constant at the end, evenly. Okay? So what do you need to remember about graphing using slope-intercept? Plot the point containing the y-intercept on the y-axis. That's always just find that number at the end. Or it pairs up with 0 if you're doing the table. And then get a second point using slope. In other words, find the slope and then you do up and over, up and over, up and over. And then connect the dot. Straight edge is nice. If you don't have a straight edge, it's not the end of the world. Okay. All right. So graph the line y equals 2x plus 3. Then graph the line y equals 3x minus 2. Then graph the line using the slope intercept. Do it also using xy intercepts. And likewise for the last one. Well, I'll give you a little hint. The answer to the first one is actually on the screen. But you can go through and write what the slope and the y-intercept are, confirm what this is. Do all 4 of these this time, not one at a time. And I will go through the answers with you on when you're done using stop start. Go ahead. Okay, so with the first one, the slope is 2 or 2 over 1. I put the over 1 for emphasis. You don't need it. The y-intercept is 3. So we begin at 3. And then we go up 2 over 1, up 2 over 1. Fill in the backside if you wish. For the next one, the slope is 3 over 1. The y-intercept is negative 2. For the next one, to do it with intercepts, I'm not going to do it for you with the slope y-intercept. It works out to be y equals negative 1/2 x. But to do it with slope intercepts, the y and the x-intercepts are the same. They're both 0. So that means you have to find the second point. So pick any value you want to plug in. I plugged in 2 for x. Y works out to be -1. And then the next one is when y is 0, the x-intercept is equal to 3 because the y term drops out. 4 times 3 is 12, so x-intercept is 3. When the x is 0, the y works out to be -4. Okay? So going back to graphing the first one, the y-intercept is 3, up 2 over 1, up 2 over 1, and we draw the line. Okay? Let's get rid of those points. Next one, number 2, the y-intercept is -2, up 3 over 1, up 3 over 1, and I filled in the backside a little bit. There's my line. Next one, the first x and y intercept is at 0, and then we said another point on that line is 2, -1. And there's my connected dot. Remember I had said the correct graph is y equals -1/2 x. And if you do that, the y-intercept is 0, and it's down 1 over 2 for -1/2. And last but not least, when y equals 0, the x-intercept is 3. There's the dot on the x-intercept of 3. When x is 0, the y-intercept is -4. There's the dot on -4. And connect the dot. There's the line draw. Okay, so those are both techniques with graphing in front of you and done properly. Okay, the big trick that I don't want to call it big, but the one thing you have to remember is in the case of problem number 3, if you get the point where the x and the y intercepts are both the same, that is 0, if they're both 0, then you need to use a second point to get the determination of that line. All right, so there are 2 ways to write the equation of a line. The first is the general equation of a line, y equals mx plus b. We need 2 items in order to write the equation of a line in the standard form, the general equation of a line. We need slope and we need y-intercept. So I could say write the equation of a line with the given information. If the slope is 3/5 and the y-intercept is 7. What's the equation of that line? Yes, this is as easy as it seems. Y equals mx plus b is the general form. The m is 3/5. It will replace, I'll substitute 3/5 for the slope. And the y-intercept is 7. I will substitute the 7 for b. And I'm all done. That's it. All done. Y equals 3/5 x plus 7. Nice, simple, straightforward. Find the slope, find the y-intercept, substitute them in. Try example 2. Go ahead. Okay, so we know that it's y equals mx plus b. And we know that the slope is -2 and the y-intercept is 4. So y equals -2x plus 4. It really, truly is that easy. Once we find the slope and the y-intercept, got to find those. Example 3, slope is 1, y-intercept is 0. Go ahead. So y equals mx plus b, slope is 1. That's y equals 1x plus y-intercept is 0. And to clean that up a little bit, just y equals x. Okay, so those are as straightforward as it gets. It doesn't usually get that straightforward. We can tweak off of that, but that's more or less how it starts. Okay, the other way is the other possibility, or there's a couple of other possibilities, but the one you'll see frequently is if instead of giving you the slope and the y-intercept like we just did, we give you 2 coordinates. Now remember, you need the slope and the y-intercept. So I need to use, or you need to use, the slope formula if I'm going to write the equation of a line with the given information. If I'm going to do that, the first thing I need to do is find the slope. So I have to do the slope formula to the 2 points, and then I need to find the y-intercept, and I actually use the equation of a line to do that in either one of those 2 points. So let me go through and show you how to do example number 1, and then you will do examples 2 and 3. Okay? So with example 1, the first thing I need is the slope and the y-intercept. Let me go through and get the slope. Remember, it's y2 minus y1. That's the y from the second point minus the y from the first. over x2 minus x1, or x sub 2 minus x sub 1, which is nothing more than a fancy way of saying the x from the second point minus the x from the first. So 7 minus 3 over 4 minus 2. I have to keep that order the same. That's what all that 2's and 1's in the subscripts mean. 7 minus 3 is 4, 4 minus 2 is 2, and I get 2 as my slope. Okay, that's a nice start. What do I do with it? Well, what that tells us is part of the answer. It tells us that y equals 2x plus b, because I know my slope is 2. Now, at this point, the instinct is to say, well, I'm stuck because I don't know what x and y are. But you got to remember, every single point is always a coordinate x, y. So I can use either point. It doesn't matter which one. I substitute it in. In this case, I use the 7, 4 point. So 7 is y, because remember, any point is x comma y. That's comma 7. So the 7 is y, and the 4 is x. So I get 7 equals 2 times 4 plus b. 7 equals 8 plus b. Subtracting 8 from both sides, and I get b is negative 1. Now I just take that negative 1 and I substitute it into the equation, and I get y equals 2x minus 1. Okay? Your job now is to do that for example 2. Do a stop and start. Follow those steps. Let's see how you do. I'll go over it with you in a minute. Okay, so remember, the first thing we need is the slope and the y-intercept. So let's find the slope. Doing a little subtraction here, 14 minus 5 over 4 minus negative 2. That's 9 over 6. Reducing, which you don't have to do, but you really should do, is 3 over 2. So that gives me y equals 3 halves x, because I know my slope is 3 halves, plus b. I can use either point for x and y. I'm going to actually end up using the first point, because the second point, I'm sorry, because there's no negatives. If I can avoid negatives, I like to. So the y is 14, the x is 4. So 3 halves times 4 is equal to 6. So 14 is 6 plus b, subtracting 6 from both sides, and I get b is 8. So now I know my slope is 3 halves. That stays in front of the x. And I know my number at the end, my b, is positive 8. So I get y equals 3 halves x plus 8. Okay? All right, so now you have 2 examples in front of you. Let's see you try example number 3. Okay, so as we said before, we need the slope and the y-intercept. You can see the process doesn't change. Okay, so the slope is going to be, oh boy, I made a mistake here. I made a mistake. So let me go to correct it. And this should be a negative 4 right in front there, which makes this a negative 6. Which makes this negative 6 over 3, which reduces to negative 2. So that makes this negative 2x plus b. Oh, that says 21. Negative 2x plus b. Just make that a little wider. There we go. Good. So let's see here. Negative 2x plus b. Negative 2 times 3 is negative 6 plus b. And then adding 6 to both sides, I get b is 10. So this becomes plus 10. And let me go back to my play. Important for you to see just how this is done. Okay. All right, so how does this look? I need the slope and the y-intercept. To do that, I go negative 4 minus 2, but my mistake before was I forgot about the negative, over 3 minus 0, which gives me negative 6 over 3, which is negative 2. So that gives me y equals negative 2x plus b. again, I can use either point for y. It's kind of funny here. I think I'm going to have to make a correction here again in a minute. Y equals negative 2 times 3 plus b. So negative 2 times 3 is, oh, see, I forgot the negative in front of that 4 also. So let me go through and I knew that in just a minute. See, this should have been a negative 4. Negative 4. And that makes this 2. And that makes this 2. So let's go. Okay. It's very important to see how this is done. I'm showing you now how a trained professional handles an emergency situation. And it also shows the importance of the process, because the process doesn't change all the way through. So the slope is negative 2. We know that. So it's y equals negative 2x plus b. And I can use either point at this point in time. I could have just chosen the first point. This is how I knew I made a mistake and said, oh, the y-intercept is 2. It pairs up with 0. But I chose the second point to show that it would also work. So I'm going to get negative 4, that's the y value before I made positive 4, which was where my mistake was, equals negative 2 times 3 plus b. Negative 2 times 3 is negative 6. Adding 6 to both sides, and I get b equals 2, which gives me y equals 2/3 x plus 2. So whether I calculate it and come out with a y-intercept of 2, or just look at the 2 that pairs up with 0, I could use any point on this graph. It will always work out to have a y-intercept of 2. And there is my correct answer.